So let's play the short, and then we're going to get Matt's response.
I am currently deep in the heart of Texas, but I want to take a second to answer this question. It's a really good question. The term mitochondrial Eve refers to the fact that we all get our mitochondria from our mothers. Sperm cells do have mitochondria, but they're only in the tails. And when the sperm and the egg fuse, the tail falls off. And so at the end of the day, all the mitochondria in your body came from your mother's egg cell. Now, similarly, there is a Y chromosomal atom because Y chromosomes can only exist in sperm cells because why would an egg cell ever have one? So this kind of perpetuates this idea that we came from two people, a Y chromosomal atom and a mitochondrial Eve. But no, that's not accurate at all. In fact, genetic analysis shows that those two people would have lived about 100,000 years apart. So no, it just doesn't make any sense. And this is why scientists should really stop using things like poetry and mythology to try to make things make sense, because while it is very pretty, it just ends up causing more confusion.
Lots of assertions in a 30-second video. Isn't that right, brother?
Yes, it is. That is a very simplistic way of looking at something. You can already tell he didn't dig deep, like at all, which is sad because it's an instructional video, right? That's a science video is what he was giving, a science lesson.
Many people are going to blindly believe that what he's saying is true. Yeah. And it's just assertions, claims. He's out of date, even just on his whole argument that mitochondrial Eve and Y chromosome atom were separated by, 100,000 years or so. And so why don't I want to say, remember a couple of years back, we did like a 3-hour response to that PBS video.
Oh, yeah.
That basically was a detailed attack on a literal Adam and Eve.
Right.
That was comprehensive. And so, to the chat, we've done full 3-hour shows refuting the critics on these points that Forrest brought up. And so we're going to respond to it now, but you can also get hours and hours worth of responses too. So Matt, did you want me to share your screen, brother?
Yeah, for sure. And while you're doing that, it's already on there. Yeah, as you can see, I typed in, show me a picture of the evolutionary believer named Forrest, and this is what came up. I'm just messing around.
That's basically the kind of that's kind of the kind of research he's doing to come up with these arguments.
Unfortunately, if you actually Google mitochondrial Eve or Y chromosome atom, that's what'll come up though. It'll only show you the evolutionary viewpoint from phylogenetic trees. It doesn't show you the actual empirical data that comes from something else, which we're going to get into in just a minute. I checked out his channel. He is actually educated, and biology and genetics are his thing. So we are going to pick that apart real quick. Okay. So I just hope everyone can see. I might adjust a little bit to make it easier. That's helping a little bit. Okay. Here we go. So when he got those numbers, he was looking at this from the evolutionary standpoint only of a molecular clock that's based on the fossil record, meaning he assumes that there was a split between a human and primate about 7 to 7.5 million years ago. And you can see that they calibrate the molecular clocks to fit this. Okay, so we know that this is true because when we look at this, we can find here that the studies that measured mutation rates in human populations using pedigree studies have reported that the values differ significantly from rates that are phylogenetically compared to human and chimpanzees, meaning what we observe is not what we see based on evolutionary standards. Why? Here's a Wikipedia answer to that. Very, very simple. They look at the phylogenetic base, which is the assumed rate of a split, and they ignore the above version of the pedigree-based one, which is the empirical rate that we actually see when we look inside of humans. So therefore, they like going off of the assumed ancestry, and they look at and they make up their own rate based off of that. When we look at just some of the earlier studies, we can go back to Parsons, which was probably the second or third mutation rate in 1998 or 1997. 1997. He came out with a mutation rate and a substitution rate, looking at all of the different blood samples he had while working at the FBI. While doing this, he found that mitochondrial E lived about 6,500 years ago. And this became known as the empirical rate, and the FBI uses it today. So it has to be accurate. And what I mean by this is if you decided to go out and kill somebody and they came and they got the DNA, they said, okay, they come over to the house and they arrest you and your family. How do they know between whether or not you or your dad did it? Well, the fact is your dad has a very similar to you, but he might not have as many mutations. You'll have more. So they'll look in the blood, they'll find that extra mutation that you have, and they'll guarantee that you are the murderer and not your dad. That's what gets usually fixed up right here. So what happens then is when they looked at O.J. Simpson's case, they found blood, but they found an extra mutation, and they said, well, it couldn't have been him. What they didn't realize is it was actually his son that probably did it. So off on a tangent on that. So what that means is Parsons found that there was one substitution every 300 to 600 generations, but it's not that's way too fast for evolution to be true. But there's also multiple other stories as well, and multiple other studies, I mean, and all of the studies get a most recent common ancestor just thousands of years ago. This is much faster than expected. 20% faster than expected. And when people challenge Parsons to this, when we specifically asked him, like, what's going on here, he said that his rate will be no problem. Okay. What he obtained, he would obtain no matter what, again and again. How do we know that? Because he actually did run the test again the next year, 1998, with a scientist named Holland. And Holland and him ran the numbers again, and they were drastically off the phylogenetic assumption rate based on evolution. They were way off, and again confirmed the earlier results, finding a slightly faster mutation rate, but it doesn't matter because, again, we're comparing the two and we're finding out which one is true. Is evolution true? Or when we look in human beings, are we finding young Earth creation is true? Again, we find this in multiple peer-reviewed studies that have nothing to do with one another, and they're always looking at the population of different groups of people, whether or not they're related, unrelated, doesn't matter. We'll get into the specific studies. And as you can see, it's pretty much down the line. We're all getting our most recent common ancestor just a few thousand years ago, no matter where we look. Here was a lichen cave where they found a tooth about 4,000 years ago, the most recent common ancestor. We'll look in this one, which was a study that was done on a mathematical simulation. And they got, again, the most recent common ancestor just a few thousand years ago. So they wanted to say, well, maybe it was there's something they weren't accounting for, like heteroplasmy and stuff like that. It actually made matters worse for them. And then a lot of people say, well, Dr. Jensen, when he ran his numbers, he didn't take things into consideration like coalescence. Well, actually, he did take that into consideration. So that's out of the window as well. Then we'll hop over here and we'll look at this one, which is a hunter and gatherer southern one. It was inferred about this when we were looking about the association being limited between genetic samples, where they were looking at archaeological remains and trying to figure out, like, well, what's going on here? This is because what happens is what we talked about earlier, is that population sizes determine on when mutations reach fixation. And when they reach fixation is based on how many people there are. The smaller the amount, the easier it is to get the top of one, and therefore that mutation becomes fixed. So again, when we have a small population, bam, we get a mutation, and then pretty soon everybody has it. That's what haplogroups come from. We can also see here in this study that fixation is actually reached really quick, and so it was from genetic drift. And then when we look back at all the different studies, I listed them all here. We can go back to 1992 and then 1996, which is from Luddstorm, and then in Howell. He only ran females, but he got 200 to 300 generations ago. And then in 97, we get about 350 to 400 generations ago. You'll notice the common theme here, by the way. All of these are very recent outcomes when we look at the observed mutation rate versus the phylogenetic one. Dr. Nathaniel Jensen was at the bottom there. He ran his on a pedigree study that was done on 666 individuals, and then he made a prediction based on how many we would see based on that time frame and how many evolution would expect based on the same thing. Theirs was off by an astronomical amount. So we can see when we line these up, chimp versus human on the left, we've got everything from as low as 72,000 years ago to an upward amount of 300,000 years ago. That's a difference of 228,000 years, right? And yet every single pedigree study that's ever been done doesn't even come remotely close to their lowest estimate at 72,000 years. So then we can get into the Y chromosome. This one is even more amazing because the mitochondrial DNA is about 1,600 or 16,500 base pairs, right? So it's very small because the Y chromosome is almost 60 million base pairs. So it tells you a whole lot more of the story than just the mitochondria does. So knowing that, which one is going to be true? Are we going to look over and see evolution? Are we going to find this massive amount? Or are we going to find the young Earth creation example? Well, Dr. Nathaniel Jensen wanted to do the hard work, so he started reading pedigree studies that were done on the Y chromosome, and there were 4 of them. The first two that you see over here in 2009 and 2015 had a very, very weak look at the Y chromosome. They hadn't even actually counted all the differences. It wasn't until 2015 that Carmen et al. And his group decided we're going to sequence the entire Y chromosome using a more advanced technique. We're going to scan it multiple times and we're going to actually find out what's going on. And they did, and they found a high rate of mutations inside the Y chromosome, higher than ever before. And by doing so, they said, this isn't good. Basically, in a nutshell, they said this isn't good. These findings prompted us to explore additional filters, which means they don't like the outcome. They didn't like the results. They were way too fast. They were probably going to lose their grant money. So they published the answer on another section while ignoring the sections that had all the mutations in it. So one thing that was really good about that, though, is that while we looked at the Y chromosome, sorry, I clicked on something wrong. We found out that this study right here gave the very most information of all, because they did what's known as high sequencing data, which means look at on the bar on the left showed all the mutations that were missed from the other studies, because what they did is they scanned the Y chromosome multiple times. They scanned it, and then they scanned it, and then they scanned it. And when the more you scan it, the more mutations you find. So this is how many mutations were actually missed in the original studies. That's a lot of mutations. So Nathaniel Jensen said, we're looking at about 4,500 years worth of mutations. And that puts the evolutionary model of predicted timescale off by a dramatic amount. And so when we look inside there, what did we find? Well, we found about 3 mutations per person on average. Well, the average person has 440 mutations. That's just 146 generations ago. So that would place a person with a 30-year generation time about 4,380 years ago, or with a 35-year-old generation time 5,100 years ago. So that Nathaniel Jensen placed the most recent common ancestor, Noah, being about 4,500, give or take, right in there, around the mid-range. This was actually more confirmation when we started looking at haplogroups, and he published this in his book called Traced, where he actually found that around the 6th generation, this person had 16 mutations, and then there was an explosion in all of the different haplogroups. And that aligns perfectly with scripture, showing that this is the generation of Peleg, when the languages were distributed. So that's amazing. So it's more confirmation that matches the biblical mutation, or the mutation rate that we would expect to find, and we did. And now for the curiosity example of all of these things. Human history only goes back about 5,000 years. It also, they publish this. These are in magazines, right? And then we can go around and we can see it. Geographical regions in Africa, about 5,000 years. We go back to the earliest pyramids, about 5,000 or 4,500 years ago. We found the Tower of Babel inscription. So, fossil paleontological evidence that existed as at least as a story. And then what do we find? We find about 5,000 years ago, civilizations everywhere started arising. They started picking up. And then here's another inscription of that. But yet when we look in Africa, what do we see? We only see a couple haplogroups there. But what would we expect to find if the biblical narrative was true and people were in Babel and they dispersed from there? We would think that that's where most of the mutations would arise. Look at that. That's exactly what we do see. This is the center of diversity for the expansion and explosion for all of the haplogroups that come out of that region of the world. Exactly what we should see. What about right here? Yeah, writing systems, same time. We go back about 5,000 years. Look at that. All of history right in that little window. But yet they want us to believe that 195,000 years of human history passed without anybody ever doing any of these things. And then bam, it's just an explosion right here. Look at this. Recent shows Indian migration from Australia. So much for the Aboriginals living there for 50 million years. Here we go. They're only 4,000 years from the new genetic data. How come they haven't speciated yet, right? Genetic drift would allow them living on that island, clearly diversifying and speciating without that amount of time. We would never be able to breed with them. And as I mentioned earlier, phenotypic diversity is the exact same between every race and group of people in the world. There's no hierarchical pattern there. That's exactly what we should see if all people are related right off the ark. And there's 3 groups of people coming from Ham, Shem, and Japheth's line. I put this in here, but that's too much to go over right now. Instead, we would see an African line being much more divergent because they had lived for much longer before we actually got out of Africa. Or if we diverged from Neanderthal hundreds of thousands of years earlier, then the Caucasians would be much more different phenotypically. But that's not what we're seeing. So, oldest trees in the world only go back to, again, right around 5,000 years. We get the math goes back 5,000 years. What a shocker. I know, right? We get fossil record evidence of, what is this? Sorry. Historical records. We've got, how old's the oldest desert in the world, right? We're going back again. We got about 4,000 years ago. Sahara Desert starts popping up. Bam. How about genealogies? People have unbroken chains of genealogies going back in history, especially royalty, because it all mattered from blood, and their blood genealogies trace right back. This is the British King's List in the museum in Britain that shows a genealogy going right back to Noah himself, and those exist all over the place. This isn't random. And then we have flood stories and traditions that go back, and they all have a very consistent theme, and most all of them have 8 people that survive. And no matter where in the world you go, and you go to Cambodia, Guatemala, you go to Australia, you go to Africa, you go to Egypt, they have one thing in common. They have pyramids. And these pyramids are very unique because they all contain a very consistent theme. They're all actually built off using the same mathematical concepts of using the meter. Now, how would that be true unless we all came from a group of people that were using the same thing at Babel? You know, we look at ancient writing systems. They can be traced back again to the same story of biblical creation in writing systems. So even though the writings and languages were broken up, they diverged and they took these stories with them. How about human population growths? Human population growth fits right in with biblical creation. It doesn't match the evolutionary model yet again. These are all short things. Here's one. Mutation rates just randomly pop up 5,000 years ago. What a shocker. We have Mendel's accountant, right? What building is that in the background? You recognize that? That's right there. That's the NIH and the National Health Institute. Guess what they're using? They're using John Sanford's Mendel's accountant for biblical creation. Why don't they use some evolutionary model that talks about mutation spreading? It's because they're not true. They only care about what works. They don't care about creation versus evolution. Yet there they go. They use the young earth creation model to do it. That tells you right there everything you need to know. And Mendel's accountant, if you want to see a little bit more on it, here's a study that you can find probably on Answers in Genesis. I highlighted it. You can also run the program yourself. You can implement your own starting situation. You can your base foundations of people. And here's an evolutionist that said it pretty well. I don't know if it's not going to play. I shouldn't have tried. We could just end off with this one then. We don't need evidence. We know it's true. That's what they believe about evolution. It doesn't matter how much I can point to things that don't match and how much inconsistency there is with their model. They've already made up their mind, okay? So I'm just saying, take another step back. Use statistical probability. What are the statistical probability that humans everywhere from every different group that there could have possibly been in the world, all waited 195,000 years just to come up with the exact same concepts, timing, math, writing systems, language, farming, agriculture, all decided to just build pyramids exactly the same around the world. It's hard work. Let's just do the same thing anyway. Let's use megalithic stones, because why not let's make it the hardest possible thing we can ever do. That totally makes sense, right? So I'm just saying that it's very peculiar that if young earth creation is wrong, that everything seems to point to it. That's all I got to say, man. I'm out.
That's all I got to say. I'm out. That's the perfect way to wrap it up. And so, Forrest, if you feel like you can debunk that, we've had an outstanding evolution debate challenge for the last year and a half. So bring it on, especially the topic of ancestry, Matt, our main focus.